Ladies and gentlemen, a pleasant day to each and everyone. Today, we'll learn another topic. Now, let us start with this question. Which of the following statement is true? What have you observed inside the box? There are five shapes consisting with squares and circles. So, letter A, all circles are yellow. Letter B, all squares are yellow. And letter C, all yellow shapes are squares. So, which of these statement is correct? Now, what do you think is the correct statement? Yes, letter B. As we can observe, all squares are yellow. So, why letter B and not A or letter C? So, let's start off with letter A. All circles are yellow. We can clearly see that this circle right over here is color black. So, basically, and it is not letter A. Letter C. All yellow shapes are squares. Basically, we can see that there is a yellow circle here. We can say that and letter C is not a true statement. Now, letter B, all squares are yellow. We can clearly see that these three squares are colored yellow. Thus, the correct answer is letter B.
So, how do we know if something is real or just nonsense? That's what logic helps us find out. Logic is the study of reasoning. It teaches us how to tell whether a statement or conclusion is true or false based on facts. In math, logic helps us prove ideas. In daily life, it helps us make sound decisions and avoid errors in thinking. For example, if it rains, then automatically the ground is wet. That's logic, connecting cause and effect through reasoning. So, logic is just a tiny step in learning propositions. Next, what is logic? So, what is logic? Logic is the study of the techniques and principles used to differentiate accurate reasoning from inaccurate reasoning. This means that logic helps us determine whether a statement or argument makes sense and whether the conclusion truly follows the given information. In the context of propositions, logic focuses on statements that can be classified as either true or false, but never both at the same time. For example, 2 plus 3 equals 5 is true, while 2 plus 3 equals 6 is false. These statements are called propositions. Logic helps us combine these simple propositions using logical connectives such as and, or, not, if, then, and if and only if. By using these connectives, we can create compound statements and then use truth tables to test whether those statements or arguments are true or false. For example, let P equals it is raining and let Q equals the ground is wet. If both P and Q are true, then the compound statement P and Q, it is raining and the ground is wet, is also true. But if one of them is false, then the entire compound statement becomes false. This process shows how logic helps us to see connection between statements and their truth values.
I am back. Thank you, Benjamin, for explaining what is a logic. Now, let us have here what is a proposition. So, a proposition is a declarative sentence that is either true or false, but not both. It cannot be a question, it cannot be a command, nor a wish. It is just a clear statement that can be answered by true or false. It is the building block of an argument. For example, in an architecture, the building blocks of a house or a building is bricks. Now, here in proposition in logic, the bricks are the proposition while the buildings or the houses are the logic. So basically, we cannot make any logic, we cannot make any houses without the building blocks. Or we cannot make a logic without a proposition. If a proposition is true, then its truth value is true, which is denoted by T, the capital letter T. Otherwise, its truth value is false and is denoted by the capital letter F. So, here's another question. Determine whether the following is a proposition or not. Letter A. Mindanao is an island in the Philippines. Letter B. Welcome to the Philippines. And letter C. 3 plus 5 is equal to 8 and 6 plus 6 is equal to 12. Lastly, letter D. Go out and play with your friends. So, letter A. What do you think is the answer? Can it be answered by a true or false? That is right. Mindanao is an island is a proposition. Letter B. Welcome to the Philippines. If we clearly analyze the statement, can it be answered by a true or false? No, since it is a welcoming statement, meaning the statement welcomes people here in the Philippines. Letter C. 3 plus 5 is equal to 8 and 6 plus 6 is equal to 12. What do you think is the answer? Is it a proposition or not? That is right. Letter C is a proposition since there is a proof that 3 plus 5 is 8. This is 5, this is 3. If we combine both of them, it makes 8. And 6 plus 6 is equal to 12. Since if we add 6 to 6, it will have a sum of 12. Now lastly, letter D, go out and play with your friends. This statement clearly emphasizes a command statement wishing his or her child to play with his or her friends. So this is not a proposition since it is a command statement.
So now let us talk about the first type of proposition, which is the simple proposition. So what exactly is a simple proposition? A simple proposition, it is a short-term statement that does not contain any other statement as parts. It cannot be broken down in the order into component proposition. In simpler terms, a simple proposition expresses one single idea and cannot be broken down any further into smaller statements. For example, Luzon is an island in the Philippines. So, can we still break this down into smaller statements? No. Therefore, this is a simple proposition that expresses a single idea that Luzon is an island located in the Philippines. Another example is we have 5 is an odd number. So this is a simple proposition that cannot be broken down into smaller statements and expresses one idea or one single idea that 5 is belongs to the set of odd numbers. And that is all for the simple proposition.
Hi, good day everyone. Now let's talk about compound preposition. So what is a compound preposition? So compound preposition is a preposition formed from simple preposition using a logical connector. So you may ask, what is a logical connector? In logical connector, we have not, and, or, if, and then. Okay, now I have some examples. In my examples, we're gonna turn simple preposition into compound preposition. So we all know that simple preposition does not contain any other statement. And in compound preposition, we are using logical connector. Okay, example number 1. In simple preposition, we have it will rain, and the second one is I will bring an umbrella. So let's turn that into a compound preposition by using logical connector and. So in result, it will become it is raining and I will bring an umbrella. Example number 2. So we're gonna turn a simple preposition into compound preposition. So our simple prepositions are I will go to school and I will stay at home. So by using logical connectors, we are able to turn that into compound preposition. So it will become I will go to school or I will stay at home. So there we just use logical connectors or. Okay, down to our last example, example number 3. So we're gonna use logical connector if and then. So first, we're gonna state our simple prepositions first. So we have you study hard and you will pass the exam. So by using logical connectors if and then, it will become if you study hard, then you will pass the exam. So there you have it. But there we just turned a simple preposition into compound preposition by using a logical connect. So there, in my examples, we were able to identify what is simple preposition and compound preposition and what is the difference between them. So just remember, in compound preposition we use logical connector. So I hope you understand what is a compound preposition really is. But we are not finished because there are 5 types of compound prepositions that will be discussed by my co-discussants.
As you can see in each example, we use logical connectors, which makes it a compound proposition. And here are some examples.
First example is using the word not. The student did not go to school today. Second one is using the word or. He will go to school or stay at home. The third one is using the word and. The sun is shining and the birds are singing.
A pleasant morning to each and every one of you. I am Jamie Villanueva, your discussant for the topic negation. So, what is negation? Negation is the denial of something. It is turning the truth statement into a false one. So, for further explanation, let me show you. Negation is denial. It is denoted by a curl or a tilde. A tilde is just a curled up dash. So, like this. So there's a truth table for this. When your propositional value, which is denoted by P, is true, then your negation must be false. And if your propositional value is false, then your negation must be true. So your propositional statement must be true, is true, then your negation of it must be false. So for further explanation, let me show you an example. What? The sky is blue. True, the sky is blue. But if we say that the sky is not blue, then that is false, since we all know that the sky is blue. So negation is just turning the truth into false. It is the opposite, turning the statement into the opposite of it, which is from truth to false and false to truth. Understand? Negation is a way of expressing the opposite or denial of a given statement. Easy to understand.
So now let's talk about conjunction. So what is conjunction? Conjunction is a truth functional, meaning and symbolized by this symbol. The conjunction P and Q is true when both P and Q are true, otherwise false. A conjunction is a logical connective that combines two proposition statements and is true only when both statements are true. So here's the table of truth of P and Q, where we can see P is true and Q is true. Therefore, P and Q is true. If P is true and the Q is false, P and Q is false. And when P is false, then Q is true. Therefore, P and Q is false. When P is also false and Q is false too, then P and Q is false. For example, P is equals to it is raining. Q is equals to I am carrying an umbrella. So P and Q, it is raining and I am carrying an umbrella. This statement is true only if both it's raining and you have an umbrella. Next example is P is equals to 4 is an even number, which is true. 4 is greater than 2, which is also true. So P and Q, 4 is even number and 4 is greater than 2, which is the statement is true. So for the last example, which is the false case, P is an even number, which is false. And Q, 5 is greater than 3, which is true. P in Q is 5 is an even number and 5 is greater than 3. So P and Q is false because P is false. Therefore, 5 is not an even number.
Next, we have disjunction. Disjunction is a compound statement formed by joining two simple propositions using the word or. For any two propositions P and Q, their disjunction is denoted by P v Q, which means P or Q. The disjunction P v Q is true when either P or Q is true, otherwise false. Example, our P is you study your lessons and our Q is you pass the exam. Then the disjunction P or Q means you study your lesson or you pass the exam. The truth table of a P or Q. So for the table, we have P, study, Q, pass, P or Q, study or pass. So first we have DT is to true, and DF is true, and FT is also true, and FF is F, which is false. The statement you study your lesson or you pass the exam is true as long as you study or you pass your boss.
Conditional or implication. For any two propositions P and Q, the statement if P then Q is called an implication. It is denoted by if P then Q. For any two propositions P and Q, the statement if P then Q is called an implication. It is denoted by if P then Q. So this means when you have two statements, P the first one and Q the second one, you can form a new statement if P then Q. This is written as if P then Q and means that Q depends on P. So for example, it is raining. Your P is it is raining, and your Q is the ground is wet. So if it is raining, then the ground is wet. So this is your if P then Q. P is called the hypothesis or antecedent or premise. Q is called the conclusion or consequence. So this means P is the condition or cause, and Q is the result or effect. So in the example earlier, if it is raining and then the ground is wet, our P there is it is raining or it is the hypothesis. And our Q there is the ground is wet or the conclusion. Next example. This example is false conditional statement. So our P is a shape is a rectangle and our Q is it has 4 equal sides. So if P then Q is if a shape is a rectangle then it has 4 equal sides. This is false because not all rectangles have 4 equal sides, only squares do.
Thank you, Erica, for that explanations and examples. Now, let me show you the truth table. If P is true and Q is true, the whole statement is true. If P is true but Q is false, it breaks the if-then rule, which makes the statements false. If P is false, the conditional is still true because the condition didn't happen. If P is false, it doesn't matter what Q is, the condition is true. You can think of it as a promise. If P happens, then Q will happen. When you keep the promise, which is P is true and Q is true, it's true. When you break the promise, P is true but Q is false, it's false. When the promise never applies, which P is false, you can't say it's broken, so it's true by default. That is all for condition or implication.
So next is biconditional or double implication. So what does that really mean? So biconditional or double implication is a type of logical statement that connects two ideas and shows that both depends on each other. In short, biconditional or double implication means both statements go together. If they're both true or both false, the statement is true. If one is true and the other one is not, the statement is false. Now, for example, you pass the exam is the P. You work hard is the Q. So the statement says, you pass the exam if and only if you study hard. Means both must happen together. If you study hard and pass the exam, it's true. If you don't study and pass the exam, it's still true. But if one is true and the other one is not, so the statement is false.
Conditional proposition is a type of logical statement that connects two propositions and shows that both imply each other, meaning it's true or false together. And here is the truth table or the truth value of this statement P if and only if Q. So as you can see from the truth table, when P is true and Q is true, then the result is true because both statements imply each other. And when P is true but Q is false, then it don't match each other, so the result is false. And when P is false and Q is true, then again it don't match, so it's still false. And finally, when P is false and Q is false, then it's true because it has the same truth value. So a biconditional statement is true only when the statement has the same truth value or the proposition has the same truth value.